This is old electronics fan, and this is, well, it says Victor on it. Theoretically, it's an RCA Victor, R52, I believe. And it's a beast. Someone was selling a house, and this radio was one of the last things that had to be moved out of the house if somebody didn't come get it. I guess it was going to be junked. So it's very tall. You can't tell from here, but the legs on it are long, and that's a lot of radio. This is very similar as far as the, well, you'll see when I get into the radio. It's very similar to an R35. Let's take a look at the back. Okay, oh, I got to have some lights. Okay, so this is the back side of this. The radio part is up top, right there. Down below we have speaker and the power amplifier. This seems very heavy, very tall. Just the case alone is heavy. And you have to excuse the lighting here because this is in the basement where the lighting isn't so hot, and without this external light you wouldn't get much. You wouldn't be able to see too much on this. So I'm trying to use some external lighting to try to improve how it looks. So anyway, I'm going to take all the parts out of this, the amp, the radio, the speaker, and then we'll take a closer look at it. Okay, here's everything on my bench, and getting it all in to one shot is a little bit of a challenge. I got things that sit behind my camera that, at least if I leave my camera where I normally put it, I can't come out far enough to really get it all. But we'll go at this piece by piece. Of course, this is the speaker now. I'll show you something interesting about this. It looks like they have made a little cup using the same material that the speaker is made out of, and that is the spider, or where the spider would be. That's fabric. Wow. And you see there's a little discoloration there. I believe, yeah, that's where the wires go to the voice coil. Now I'm going to check a few things out on this before I go too far with this. I'm going to start with this actually. It's not all that uncommon for the voice coil or the field coil to go bad in these old radios. I had been relatively fortunate up until recently to not run into that, but an old radio that was donated to me, one that I was rescuing, both the voice coil and the field coil went bad on that speaker, and I didn't see anything in particular that would have led me to believe that that was not in good shape. This was sitting up in somebody's attic for the longest time. Unfortunately, the case had some damage because water was dripping on a corner of the set. But, so, let's see, do I have, yes, I do have this, which tells me field, voice coil. Okay. And they give you colors, but they're not entirely helpful now because this has aged. All right. As we know, the colors fade with time on these, and you're kind of at their mercy. All right. Now, theoretically, let's see. Well, it looks like the top two. Yeah. Yeah, that's the voice coil. All right, so let's check that out. All right, fine. Okay, that's encouraging. This one's the one I really worry about. Well, I worry about both of them, but... Uh-oh. That is not good. That's a problem. That, as far as me working on this, may mean this is dead. And there are ways to get around this, but the field coil is a massive. That is massive. Yeah. Well, that's not good. This thing is an absolute monster. I mean, look at how thick that magnet is. Do they tell me, I'm just curious, what the resistance is supposed to be on the field coil? This radio is, there's some very interesting things on this. They aren't telling me. There are some things that give you lots of information on. I say lots. And other things, well, not so much. I'm poking through the documentation, and I don't know if they're going to give me what I want to know. Because if they don't tell me what the resistance is going to be somewhere, I know that the basic range, my experience to date, voice coils can range between 1100 and 1800 ohms. I'd be leaning toward a higher resistance on that one, but and there are ways to figure out what you really want for resistance, because I say that, but let's see, power transformers. On either the trouble may be in the field or voice coil. Test for voice coil. Continuity. That's nice. They tell you what to test. They don't tell you what the measurements of what you're testing, the ohms of what you're testing would be. And this is the third speaker I've run into where the voice coil is fine, but the field coil not so much. They don't seem to give me information that I want. And there's a surprising amount of information in here, but unfortunately, some of the very important stuff I want to know they're not telling me. Let's see. Let's make sure I didn't miss anything. They've got some sheets that are focused on troubleshooting, and sometimes they give you stuff like this, but to use something like that, with that information, I should say, man, that sucker's heavy. You need stuff like this. If I'm right, I believe it is. They talk about a Weston meter. When you hear that referenced, you should automatically know that the voltages or the measurements they give you are in reference to that special piece of equipment, which nowadays are rather hard to come by. They are available. I've seen them on eBay, but yeah, I just really wish they would tell me. They are available on eBay, and I don't remember what they were asking for them, but I don't recall them being all that cheap. So that's rather disappointing. Let's see. Yeah, I'm pretty sure. Let's just do this. I don't believe that'll make any difference whatsoever. But I've been fooled before by lousy connections, probably because the solder gets so old that it gets crusted and it doesn't do anything. Kind of like that. Yeah, I heard somebody talking about this, and and maybe they know from experience, but their thought was that well, it's one of two things. Well, since this isn't reading shorted, then it's probably the other thing. Corrosion gets into, yeah, we don't have no action there. Yeah. So, yeah, that's fine, but that other part is not. Okay, so, and here's where it gets challenging. If that weren't challenging enough, well, let's see. This radio is older, I'm pretty sure now, is older than the R35 that I worked on. There's a number of things that tell me that. Number one is this speaker. The speaker in the R35 is way different. It's not so massive, and this is incredible. And I'll tell you what, that thing does weigh a lot. It's not nearly as massive, it's larger, the field coil is smaller. There are lots of things that indicate to me that this is a lot older. The other thing is the simplicity of the circuit diagram. And let's see, can I just throw that? Wow. No, it's not going to work. Well, let's do this. Because I want to look at this and see what I can come up with, and we'll just do this. Alright. That allows me to get it where I want it, more or less, and alright, so let's zoom in. So here's what I'm dealing with, and I don't know if I have, let me go back here for a minute. They have some voltages. They have plate, grid, cable terminal voltage tests, and they tell you if you don't get that particular voltage, what that means. Let's see, 13 and 15. Let's see, 13 and 15. Oh, where's my schematic? Oh, it's right here. So 13 is here, 15 is here, and yeah, these two, I believe, are that's the voice coil, and then 13 and 15 are the field coil. Alright, so they are mentioning interesting. They mentioned 185 volts between, man, okay, this makes this all more interesting even. These two are the field coil, that's 15, that's 13. Now this one goes over here, goes here, and typically what you wind up with in these old radios that have electrodynamic speakers is you have voltage coming, let me think, it varies, but basically you feed voltage through the field coil, and usually the field coil, that's it, usually the field coil is part of the pi circuit. Your B plus comes in, goes through the field coil, feeds up, goes up to the output transformer, and then feeds the plates of these two tubes. Now this is where this gets interesting. One leg of this field coil does go there. But here's the other question, here's the question I have. This is the other one. It goes down here, goes over here, goes up, no, that's the wrong one. This one. Where are you? 15, 13. Okay, 13. That's the one I want right there, 13. So 13 goes over there, goes up here, goes over here, and goes into this transformer. And I sat looking at that for a while, and I'll confess I'm a bit puzzled. Because if you follow the leg going out of that, it goes over here to this radio record player switch, and then it goes up here to this plate on the output tube. Now this is supposed to be, I don't know, plate voltage on that tube, is it telling me? Of course not. That's power amplifier. Yeah. So they're keeping that a secret. The documentation for the R35 was better than this, and extremely nice to have. Radio voltage tests. Okay. Plate. Oh, socket number. If I had to guess, they aren't telling me. Lovely. They have numbers on the sockets, and I'm not crazy about how they've laid this out. Well, are we going to get some socket numbers? No. Well, if I go with the way the other radio went, let's back this out a little bit. This was tube 1, 2, 3, 4, 5, 6. And so if I go with that in mind, if I assume that, I'll try to find something to confirm that. That means that, yes. You'll see in a minute why that matters to me. Are you? Okay. Here are the tubes, 1 through 6. It tells you filament voltage, plate voltage, grid voltage. And I'm guessing that the plate voltage on the 27 tube is 105. So the question I have is, well, let's go back, let's go in here a little bit more. This is where it gets so weird. And maybe if I knew more, this wouldn't be so confusing, but alright. This is the 80 tube. This is the rectifier. It's a full wave rectifier. It's got 2 plates. That's the filament right there. This is the filament winding. This is the center tap. Now, let's start with that. Newer radios do not have a center tap on the filament for the rectifier tube. They don't use it. Number 2, either one leg or the other of the filament is the B+ connection. And that's not the case here. This is your B+ coming out of here. Then it gets even more interesting. Look at this. That looks like, I'm not sure what that looks like. If I look at the listing of parts, and because it looks like a C9 and C10, one of these is supposed to be a 2.5 and the other one's supposed to be a 3 microfarad, which would imply that this is a pi circuit. So there's your coil. That's a choke, basically. It's not your field coil, it's just a choke they put in. So B+ goes through here, gets filtered, and then goes out here, goes up there, and that's where it gets really interesting, because normally this, oops, let me back up because you didn't see most of that. Alright, let's start that over. Alright, so as I mentioned, this feeds out of here, goes up to this and feeds those plates. So far so good, kind of. Comes out of here, goes over here, goes through this, goes through here, goes back out of here, goes there, and goes up here, which is really weird that they're doing that. I'm not sure why, but anyway, so it goes up here, unless the point is that they want to use this capacitor to do more filtering. I don't know. But this goes up here, goes over here, goes into this transformer out, goes out through here, goes up through this transfer switch, and then finally goes through this coil, which I don't know what it is, if it's a choke, could be, and finally feeds the plate of the U2, or the U, ignore the UY2 part, it's a 27 tube, basically. So, this is extremely, extremely different. So, knowing what this plate voltage should be tells me, or will allow me to figure out what resistance I need to use to replace the field coil in this, so I can supply the right plate voltage for that. That's why I was looking for that, because if those of you who have worked in this hobby for a significant length of time will know, in fact, that's just for the fun of it, will know that you can't rely on your tube manual to tell you what voltage they want to use in their radio. Because some engineers just say, we want this voltage, not that one. Plate resistance, heater volts, 2.5, plate volt, 250 max, and that 250 max is negative 21 volts. So, do I have, that's a 27, do I have a 27? No, I don't. So what I'd have to, so this manual does not give me all the information I would like to have, because when that manual was made, the 27 tube was obsolete. Not surprising. When was this done? Are they going to tell me? When was this made? Well, it's an RC22. That means that there were 21 versions. Yeah, 63. So that tube manual I showed you was published in 63. So by the time 63 rolled around, which was, I think, this is somewhere around 1930, 1929, somewhere in there maybe. It's possible for it to be a bit earlier. I'm not sure, because the information I can get on this as far as that goes is limited, let's put it that way. So anyway, back to this. So without the voltage that this radio wants to see for this, I'd only be guessing, and I would have to hunt up online another tube data sheet and find out what the range of voltages would be for that tube. So the next thing that I want to know is, so far not so good, we've got a broken fuel coil, which is not, unfortunately, that unusual. So, yeah. So, does it tell me, what does it tell me? As far as the 82, does it tell me? Plate voltage, 230 volts. Okay. Oh, so there it, okay. Interesting. I missed, see, this is also pretty bizarre. This seems to have its own winding for the 26 tube. I assume they did that because this amplifier could be used separately with something else, and I know that people do that. They use these amplifiers, get rid of the radio and use these amplifiers. But so let's, oh, don't do that. So let's take a look at this. I guess I'm going to get this out of the way. There's not much I can do with that, unfortunately. Alright, so now the other thing I want to mention, and this is important, and it's not telling me. Yikes. This sat around for a long time. There's a good chance that I am, oh, there it is. Okay, good. My, is it my outputter can? No, my R35. Somebody was playing around with the set, and now on this one, let's see if we can get some light on here. Do this temporarily. Come on, you. Right there in the middle, it tells me 280. Yeah, you can see it, 280. So that's really handy. On some radios, I think the R35 is one of them, the chassis itself has been stamped with tube numbers, which should have made it more obvious which tube went where. But, and I could have cried, somebody took the 45 tube and swapped it with the 80. And the 45 is what? I can't remember. The 45 is either, I think it's a 2.5 volt tube. I think the 45 is. And of course, when you take a 2.5 volt filament and put it on a 5 volt winding, the filament has a very short but merry life as it goes up in smoke. So that says 26, that's correct. So when I'm dealing with these old radios, I look to make sure that, oh, this is interesting. That's very interesting. This is supposed to be a 45. It says 71A. Do I? Let's see. I don't know if my tube substitution book is going to be helpful or not. It frequently is not, but let's just see. Let's go to a 47. There is no substitution. According to that, I bet this doesn't have a 71. Interesting. It doesn't even list a 71. So that's something else I'm going to have to investigate. If I'm going to go any further with this. Oh, wait a minute. Did I see something? 71A. They mention it, but that's not. So I have no clue. Yeah. These tubes are hard. Well, hard. They're expensive to get. Interesting. Well, now. That's 45. That does say. That's 45. Yeah, that's what that says. So I need to find out what that is, how it compares to a 70, or to, yeah. So I need to see how a 71A compares to 45. And that's got a lot of dust on it, so it would appear that that tube has been in there for a very long time. Maybe the person who worked on this knew something that we don't. I don't know. So that's another interesting thing. This radio is not looking too good. Alright, so let's go. Man. Oh man. Let's back you up a little bit. And let's see. All right. I have to look at my chart to see what that is, but this is a resistor. And I saw that somewhere in the schematic. Oh, that's interesting. Oh boy, this is looking less and less good. I do have a chart that tells me what the components are. It may actually give me, yeah, let's see. It tells me what the transformers are at least. And I'm curious to see power transformer 57, which is this one. That's the capacitor box. pretty sure. 62. Power transformer, same as 57. Well, that may be it. Yeah, I think that is the power transformer. Okay, it's just oriented that way. There's that massive resistor. It's supposed to be 4 k ohms from end to end. That has me worried though, because there was a wire attached to that. There's solder and there's the remains of a wire, but the wire is no longer connected. Interesting. Alright, well, let's see. What on earth? Oh, okay, so this is the block. Yeah, okay, so this is oriented that way. That's the block on top that you plug into this with. Okay, so what else does it tell me? Not much. At least those don't. Let's find some more stuff. Okay, come down to this. Alright, so, alright, let's go here for a minute. I just saw you. Oh yeah, that's that long resistor. And you've got those two. Look it like this. Alright. So there's the resistor. So we've got a wire there, a wire there, a wire there. That's 1, 2, 3. And it goes there. I wonder if that's a replacement resistor that somebody put in. It says GE, I think. I'm not sure. Kind of looks like that. Possibly this may have been removed from something, but it's the right size and everything. But yeah, there are marks. There are marks on the little clip here and on here. I think somebody's had this out and they've stuck this resistor in, because this is 1, 2, 3, 4, 5. The diagram says 1, 2, 3, 4. Interesting. Gets curiouser and curiouser. So this is indeed the power transformer. That's a busy little transformer. Okay. Cable socket power transformer. They've got color codes, and actually you can see the colors on some of these. Some of these actually are color coded still. That's kind of concerning. In fact, that looks like it's dripping, even as we speak. Yeah. That's not exciting. And that would be, what? Oh. Well, alright. Where was I headed? Oh yeah, we were going to look at the bottom of this, and I was going to try to see if I could figure out... Alright, well, I think what I'm going to do is... So this one is the 80. Alright, so let's do this first. I want to measure... I want to... talk. I want to try to make this as easy as possible on myself. And what I want to do is I want to measure the, let's move this back, filament transformers, and now if I have this right, this should be the part that has the B plus on it. Well, this is going to be the two plates, let's put it that way. Okay, so, alright, now this should be, I assume lower? Yes, okay. Filament, secondary, and this is the B plus supply. Good. Alright, and then this one, the 45 should have The 45s. Alright, where's this one? It's handy. Yeah, so both 45s. So I'm going to take the 45s out. Both of them. Well, I don't know what that 71A is. Alright, so this would be filament. Yep. Good. Alright, so we can put those back in. I'm curious, are these filaments the same resistance? 3.6. 2.5. Come on. That's less than great. Oh boy. I don't know why it keeps dancing around on me. Wow, they aren't even close. That's a matter of grave concern. That would definitely explain why the 71 is not showing up in the substitution book, because it doesn't, based on what I'm seeing. Okay, so, and then we've got a 62, or 26 rather. Alright, and let's check that one. Alright, so far all of the filament, all of the filaments are, windings are good. So the 80, the 45s, and the 26 on the amplifier are all good. So the next thing though that I want to know is, or want to see is, oh yeah, I should take a peek at the power transformer, and I've got to, let's see, what's here? I want this one. It's clearer. Well, I say that as less than clear. Does it give me? Okay. Well, let me go back, because I wrote on here what my filaments are. And there's two tubes on the radio portion, a 26 tube and a 27 tube, and pins 1 and 3 and 5 and 7, so maybe we can do that from the top. Let's find out, see if we have numbers to help us. Okay. Alright, well, this is, I know this is the speaker, and this is the higher numbers, like 16 and 15 here. That means that we're down here. And the next question is, does it matter? Okay. Well, they're showing you, is this from, oh well, alright. So 1 and 3, 1 and 3. They aren't telling you. Well, let's do this. Okay, that was a pretty good guess apparently. So 1 and 3 is a filament, and that's showing up like a filament coil winding. 5 and 7, 5 and 7, that's also. So it starts here with 1. It would have been really nice if they numbered them. Although I think they do have a picture somewhere. Yeah. Huh. That's they just simply give you the numbers and the colors of the wires, which means in order to see what those wires are, you have to take this metal cover off and then look. And they didn't put it would have been so nice if they put numbers on here or numbers on there. But I think I've got what I need. This, by the way, is the cord has, the power cord has this kind of a setup. And you plug that onto there, and then the other end has the AC plug. Yeah, my collection of fuses that I need to replace, get more of, and I haven't done that yet. Alright, so it looks like I've got all of the filaments are good. Of course, the next thing I would really like to do, and that's where it's going to get to be a whole lot of fun, is, and that speaker has me concerned. That what is in that one. It was showing me. Let's see if we can find out what that is, and we'll go from there. I'm curious to see what that is. Alright. So that's number 55. Filter choke coil. Oh. I want to see what, okay. Yeah. Wow. I did not expect this to be so insane. Filter choke coil. And I've got 2 wires here and 2 wires here. Is there anything that tells me, well, it's just for the fun of it. Well, that's 200 ohms. Come on. That's 3.5K, dancing around, but alright, so as nearly as I can tell, that looks okay. So what is 58? Interstage input and output transformer. You know what I'm going to do? Because this is just going to bore the heck out of everybody. I'm going to do my level best to sort this out. Okay, well, I've done a fair amount to this, checking things out thoroughly. I got interrupted just as I was ending the previous segment. But I wanted to stop at that point anyway, because I knew it was going to be a rather drawn-out affair. These cans fit on the bottom of this and cover all of these coils, so those had to come off. And there's actually there's 2 coils to these. You got the main coil, which is this copper-looking coil, and then this little tiny, very skinny coil. They wrapped a piece of some kind of tape around it, and then they wrapped this very thin wire for the second coil. There were some resistors here that I've checked all of these. I did check the on-off switch, and well, the on-off switch was basically open circuit. I wasn't even getting any reading whatsoever out of it. Now, I was going to just finish putting it back together. Like, let me just do this. I'm going to show you. It'll be easier. Now, When I took this apart, this big nut and this small nut were both on the outside of the case. That is not how you want to do that. It really isn't hard to take one of these apart. I used side cutters. Tried to use my dollar one so I wouldn't chop up the ends of the rivets so badly, but these couldn't get underneath it. These new ones did. I was able to peel the edges up and squeeze it together and then carefully feed it out. When you're prying against these, trying to get them the rest of the way out, pry against this, not here. It will crack this, which I just did. But thankfully it didn't crack in such a way as to damage the switch, so I was able to put it back together. So when you're putting this together, you thread this in so that you've got it pretty much where you want it. And then slide that in and put this on. And the reason I'm suggesting this is because you'll see a line around here. That was because that big flat nut was on the outside and it had sharp edges. Plus, if you're using pliers on the outside, you're going to leave a mark. The damage has already been done. I'll probably use some Restore Finish on this to kind of hide that. But what you want to do is, once you get this adjusted pretty much where you want it. Oh, and I thought they used to make a tool that would actually fit over this and had little a bunch of little fins inside that would catch the knurling on the knob, and that would allow you to tighten it up and not leave a mark behind. But here's the way I'm choosing to do it these days, and that is come on. Okay. That nut is now behind there. I get behind there and I just tighten it up there. That way I can carefully tighten it up, and if I nick things in the back, it's not a big deal. Not like it would be in front. Alright. Actually, I have a better pair of pliers for this, which I didn't grab. Yeah, I can do that. The bigger ones. Okay, now. There. And if you do happen to get big pliers on it, be gentle, because you can do bad things without meaning to. Okay, so I have an R35 which is very similar to this, but as I work on this I discover more and more that these two radios are not the same. They have the same tuning mechanism, but they don't. That's where the similarity seems to end. And there's some other things, because of their vintage, they obviously are very similar. The volume control is a dual section control, and obviously it's not because it's stereo, because this is not. But in the circuit diagram, you'll see this is on the antenna, and the volume control controls whether you make your connection here or down here. But that apparently wasn't enough for them, because then they put this coil in, and the volume control here controls whether this coil is shorted or open, yeah. If you move the volume control in one direction all the way up, it shorts across this coil. If you move it the other way, now this resistor is between there and you don't have a short circuit anymore. This coil can actually function. It's a very creative way of doing things. That's how they did that. And that's how they did things back then. Alright, so this thing, I'm probably crazy for geeking out on this, but I want to show you how this works. If you haven't seen R35, then you're going to see it here. And I wanted to go into this a little bit because I didn't do it in the R35. I didn't show what I'm going to show you now in the R35. Basically, I just forgot to do it because this is kind of important. On the other radio, there's a shaft. These are movable. If I see these move. Well, this is, it feels like it's a gear driven. The other one wasn't. You could actually slide it. But anyway, so it rotates this turntable, and each of the adjustable capacitors is connected to this. They strongly recommend that you don't monkey with this. I strongly recommend you don't monkey with this if you don't have to. If somebody's gotten in here and there's a magic screwdriver to start tweaking things, there are capacitors mounted on the ends of some of these. There's one right there. And there's 1, 2, I think 4 of them have them. But they really don't recommend you play with those if you don't need to. Thankfully my R35 worked fine, so I didn't touch it. I'm hoping this one is the same. Now, one of the things that, I don't know if you can see, right there, this is a rubber material, it looks like. This spent a lot of time in somebody's attic, and yeah, it got kind of warm, and I'm surprised it didn't destroy these. It looks like they're still okay. One of the things I look for, there's 2 things I look for on these. One is these are flat pieces of, it kind of reminds me of fiberglass. Or actually circuit board material, I guess is closer to what this is. But when you're looking at these, carefully move them and see if, another one, do they move freely? Is there a lot of wiggle? These holes can get oval, both here and here, and then you can do this one the same way. And there's a spring that goes from the center hub and out to here, and it's trying to put tension on everything. And there's a little bit of movement, but the minute you let go of it, it goes back into place. But what you're looking for is it really sloppy? And the other thing you want to know is, do they move freely? Now this one's a little bit different than the other one I worked on. It's similar. And so what I'm doing now is just wiggling them back and forth. And given where this was stored and how it was stored, that one. So you can see, actually, you can see on this one how it works. This spring is holding against this bottom piece down here. That spring is keeping constant tension on these. So these things should be loose enough that you can get a little wiggle out of them. If you can move them like this, like that, that will tell you whether this side is free. On this side, you just wiggle it back and forth, and you can also get a sense of, as you're moving this one should allow this to come back freely. And again, if you can wiggle it around, get a sense for how tight that is. So that's what I do with these to make sure that they're healthy. Since these were inside those metal cans, they're definitely in pretty good shape. But I'm looking to see, so I see over here, something actually got in here. There's a nick right there. And I think I'm going to take a file to that. Oops. I don't know if I can swing this around. It may not hurt anything, but see the nick right there? That's what I want to get rid of. So I don't really like that. Now be careful because you've got that right there. Clearly somebody had this apart, and while they had it apart, something happened to this. And it wasn't horrible, but I don't want to put this all back together and have problems with the tuning mechanism. Now, so the next thing I want to do, I've just filed that down a little bit. I want to close this together. Now I should not have a short there. And we're going to check that right now. Let me zoom this out a little bit so I can't get everything in view. Okay, I've got 4.0 ohms. Now, you're going to see ohms on this because this coil is across the tuning capacitor. But you shouldn't see this. You should see that. Not that. Come on. Let's go. Well, anyway. Yeah, you see that, you're in trouble. But this is okay. So, that was 5.3 ohms, thereabouts. Actually, let me just finish closing that up. We'll just double check. 5.3. It doesn't, for some reason that doesn't, and they're all the same. Okay, so that looks good. So let's flip it over and take a look at the top. Oh, this is interesting. The tubes that are in this. Crusader radio tubes. I've never seen those before. Guaranteed for 3 months. RCA licensed. Guaranteed better built. If found defective, return for adjustment. No claim considered on damaged or misused tubes. So I assume red plating them would be bad. Here's something else. Ward's Super Airline. And then this one was my favorite. This is an older style Philco. I have no idea how that wound up in here. I'm pretty sure that RCA wasn't using Philco tubes. But this is pretty cool looking. I like these old tubes. So all of the tubes have been changed in this at one time or another. So this radio has gotten a lot of use, I would say. So, all right, let's look at the top side here. try to be very careful of those coils. And I'm flipping it over. Trying not to do bad things to them. Alright, so this, I want you out of there. You can do bad things. This radio was about as much fun to find things as I expected it to be. Although there are aspects of this radio that are better than the R35. You do wind up going between top and bottom on this radio because some of the stuff is here, that cover that was on here, which I'm probably going to leave off as I'm playing with this, as I'm sorting things out. These are the sockets, and these are all labeled as well, which is kind of nice of them to do that. Especially since the documentation on this radio, let's just say it leaves a bit to be desired. Figuring out which tube is where in the circuit is somewhat challenging. Because you've got, let's see, how many of these? 1, 2, 3, 4. You get 5 26s and a 27. So, yeah, it gets to be interesting. This radio actually, even though this didn't have a phono, the cabinet wasn't set up for one, it had the phono radio switch. So basically, even the radios that didn't come with a phonograph have this switch in them. I'm assuming it was just cheaper to build them that way, and then they just decide which cabinet and style of radio it was going to be when it came time for them to sell it. One of the nice things about this, I don't know if that's an original switch. If it is, it's way better than what was in the R35, which is kind of interesting because I'm kind of convinced that this is an older set. I could be wrong about that, but there are indications that it is. For starters, the 26 tubes, those are an older tube. Those are directly heated tubes. There is no indirectly heated cathode in those. In fact, it's a very basic. The filament is the cathode, so there's only 4 pins for that tube. And then the 27 is an indirectly heated cathode. That's the first audio tube in this unit. That one has 5 pins. My goodness. Alright, so, oh, here's the other thing. All my years of working on stuff and working on it from the bottom has trained me to read the pins on the tubes as though I am reading them from the bottom. On this radio and on the 35, I made the same mistake. I was counting the pins from the top as though I was looking at the bottom. And I guess I could be excused for that because it's got all these components there surrounding the socket, and that's what I'm used to dealing with. Most of us are. So, if you're working on one of these and you're working on them from the top, remember you have to count in the opposite direction than you are used to. Yes, okay. That's the tar that got on my paper. Alright, there's two input coils on this transformer. One's from the record player and the other one's from the radio. Now, I don't, and this one's weird because it goes down here and then goes around here, and this coil and this coil both are tied together and go to ground here, which I thought was rather interesting. But how this works is V plus comes up here, goes through this, and comes up here to this transfer switch. If it's in radio, then this connection between here and here is made, This part right here is just, that part right in there is a little insulator. I couldn't tell from the diagram, but there's a little insulator there that keeps this the right distance apart. So when this connection is made, now the voltage goes to the plate and the radio can play, and then this is the output for the radio. When you switch to the record player, however, this connection is broken. That means that this B plus line is now disconnected. It shuts off the whole radio section. And now the radio feeds into here. And there isn't a B plus being fed into here because this doesn't need that. This is actually the pickup right here, the cartridge. And it has its own volume control right there, which I thought was interesting. So it's an interesting setup how they wired this up. The pilot lamp in this, it looks kind of like a night light, and it's 120 volts, full AC. Yeah, so this is definitely an interesting unit. You notice I've done some marking and labeling. This is because I couldn't tell whether it was 8 or 9 or 6. So when I figured out what these were, I labeled them. I also marked all of the pins so that if I have to go back and try to troubleshoot this, I have a starting point at least. So back to where I was headed though. I think the transformer measures okay. These measure good. I think all of these measured good, as far as I could tell. The only one I don't know about is this one because there's a resistor across this side of it, and I wasn't really excited about taking that apart just yet. I may wind up doing that, but my goal though is to plug this in without the tubes. In fact, I'm going to probably take the rectifier tube out of here. I have no tubes in here. So I want to check the rectifier, check the unit without the rectifier tube. There are no electrolytic capacitors in here. They are simply not there because they didn't use them back then. 1929 or whatever this was, they did not use them. Oh, just looking on this component, it has a part number. I wonder if that shows up elsewhere in the documentation. I'll have to look for that. So, but you spend a lot of time, let's see, well, for instance, I was trying to measure these coils, and then I figured out, well, I could follow this all the way back to the plug, figured out which pin it was, connected there, and then I could go to the plate of each of these tubes and see if this coil was healthy. Those are some of the ways I try to get around the fact that things are hard to find and hard to get to. So, yeah, I expected it. The other radio was similar and a pain in the neck. So, but the other thing I'm a little concerned about is the power cord. At first I thought it was going to be okay. This stuff is shiny. And I looked, well, hey, it looks better than new. But then I actually made the mistake of trying to straighten this out, and I heard crack. So this is probably healthier than the United American Bosch radio that I played with earlier. I will have this on a light bulb to start. If I don't try to unknot it like I did earlier, I might actually succeed in using this without bad things happening. But if I have to, I will take this apart and stick a new cord in it for now, of some kind. Got enough old power cord stuff floating around. That shouldn't be hard. Oh, lovely. Every time I touch this, this is what happens. Maybe I'll do that maybe I'll put another cord on this just so I don't have to deal with this anymore. It's very messy. It's shedding everywhere. So, yeah, I forget what that was. I think the capacitor block in this is leaking tar out of it, which probably means that it's maybe not all that healthy. I don't know. When I picked this up, the dust, I mean, these tubes, everything had a thick layer of dust on it. Obviously that could happen while it was being used, but the cabinet had a matching layer of dust on it as well. So this radio sat around for a very long time. The tuning mechanism intrigues me. This is right up around the same time as the Atwater Kent, which has a much simpler tuning mechanism. And if this is an early radio, this one was the forerunner to the R35 and other models that use similar tuning. So they used this not just for one radio, but they used it for one model year and a whole bunch of different radios, because there are, if I look on the, yeah, 32, 52, 45, 75, and you'll see the same thing on the R35. There's a bunch of different models that the information applies to. So I'm just amazed. This right here, these little screws, these are what tunes each of the tuning capacitors. These are rollers. Each of these is a roller. And this, each roller rides against the side of this. And the way you tune this is you adjust each of these screws so that this roller moves that tuning capacitor the right distance to put it in tune. I don't know how they did that in a factory. To be honest, I think it's insane. But at the same time, I'm intrigued by it. So I'm hoping, I've done my level best. I've done my level best to try to make sure that the remaining coils in this are healthy. I'll find out when I apply power to this thing just how well I did. I am actually going to wrap up here at this point. This is going to be part one of I don't know how many. I haven't recorded anything beyond this point yet, but I'm going to post this now, in part because it's summer, and if I wait to the end of the series, it'll be quite a while that I will be going without posting anything, and I'd rather put something up if I can. Before I do officially wrap up, I want to show you what I found out about this. 71A and the 45 tube, they are not compatible. Not a shock, but so let's zip right in here a little bit. I'll show you what I found out. 2.5 volt tube, 5 volt tube. This one has a maximum plate voltage of 180. This one has a maximum of 275. This one has 2 watts output, it says. This one says 0.79. Very different tubes. And I fully expect that this tube will pretty much do nothing. I'm not sure if a 2.5 volt filament will light at, or a 5 volt filament will light at 2.5 volts. In fact, I think this is actually, do I have, let us see. Well, the 27 tube, they're supplying 2.35 volts to the filament there. So what about the 45? Let's check that out. filament, 45, 2.2 volts. That's what it says. Take all that with a grain of salt. Sometimes it doesn't. Reality doesn't match what the manual says. But that's, we'll see. This is so this is 2.5, 5. So with much older radios, one of the ways they controlled the volume was by controlling the voltage going to the filament. Give it more filament voltage, you get more volume. Less filament voltage, less volume. This tube isn't going to hurt anything, but it's not going to contribute a lot to the push-pull amplifier in this. So I'm not going to try to locate another 45 just yet. I want to see whether or not this works, how well it works, and I'll find out at that point. Number one, did I make a mistake taking this even though it was for free? I don't know. And the other part is, do I even want to go ahead and do something with it? That again is to be determined. To be determined. There, English. So, it's an interesting, it is an interesting unit. It's definitely quite a bit different than the R35 that I worked on in a lot of ways. So anyway, I'm wrapping up here. I'm interested in seeing what happens next, but that's going to wait for a bit until I can get back on this. It's summer and there's a lot going on, so it's going to depend on what's happening, on when part 2 shows up. Hopefully not too far in the future. If you've liked this so far, appreciate a like from you, or make a comment. Subscribe would be great, and hopefully I'll see you on part 2.